Let's consider a common situation, or at least a situation that is pretty common for myself. When you go to the grocery store and you're looking for a particular item, but you aren't quite sure where that item is located, what do? Option 1. You could wander around happily, yet aimlessly like this woman, in hopes of stumbling upon the item that you're looking for. Option 2. You could decide on a particular method, such as going down every single aisle until you find the item that you're looking for. Or option 3. You could think really pensively, like this woman, of related items whose location you are fairly certain of, and then only check those related aisles. Interestingly, this type of scenario has led many scientists to study the art of decision making. These types of scenarios beg the question of why we make certain decisions over others, and further, how we go about making those decisions. Each of the options I presented to you theoretically answers the question of how in regards to decision making. How do we make the decisions that we make? If you decide to walk around aimlessly, we consider that to be trial and error. If you chose a particular method, such as walking down each and every aisle, we consider that to be algorithmic decision making. The pro to these methods is that at some point you will succeed in finding the item that you're looking for. The drawback with these two options, however, may be fairly obvious. Time. Both of these methods require quite a bit of time. Which leads us back to option 3, decision making by way of heuristics. By thinking of related items and deciding to check only those aisles, you've used a mental shortcut to arrive to your answer. Essentially, this is what heuristics do for us. Heuristics aid in our ability to make decisions, particularly when faced with uncertain events or situations. They are thought to be mental shortcuts that help us arrive quickly to conclusions by reducing the amount of cognitive processes that might otherwise be necessary. Although heuristics are great time savers and are considered to be very necessary for normal functioning, mental shortcuts do have their limitations that lead to potential errors. Take this picture. Although America arguably has other deadly habits and issues we could focus on, by being bombarded with information concerning a rare disease such as Ebola, we highly overestimate the likelihood of actually being afflicted with such a disease. Why? Because this is the information that is readily available to us. Information we use to make decisions based on how readily available the information is are considered to be a type of heuristic, an availability heuristic. Another availability heuristic? Stereotypes. Because stereotypes are also pieces of information that are readily available to us, these types of availability heuristics might make it difficult for us to remember whom this picture is actually talking about. So who are the brains behind this phenomenon? Often the credit goes to these guys, Tversky and Kamen, which would be appropriate. However, literature suggests that Tversky and Kamen were highly influenced by works from this guy, Herbert A. Simon. Herbert Simon was born on June 15, 1916, in Milwaukee, Wisconsin. He came from a relatively humble home with an engineer father and a pianist mother. Influenced by his uncle, whom studied economics and psychology at University of Wisconsin under John R. Kamen, Simon discovered the social sciences. In 1933, Simon began studying at University of Chicago, following his initial interests of social sciences and mathematics. The social sciences, he states, needed the same kind of rigor and the same mathematical underpinnings that had made the hard sciences so brilliantly successful. He was prepared to become a mathematical social scientist. His most influential mentor at University of Chicago was Henry Schultz. Simon describes his path as more happenstance than anything else. An undergraduate field study for a term paper developed an interest in decision-making in organizations. On graduation in 1936, their term paper led to a research assistantship with Clarence E. Ridley in the field of municipal administration. The research assistantship led to a directorship from 1939 to 1942 of a research group at the University of Berkeley engaged in the same kinds of studies. Simon states, By arrangement with the University of Chicago, I took my doctoral exams by mail and moonlighted a dissertation on administrative decision-making during my 3 years at Berkeley. Simon published one of his most well-known books, Administrative Behavior, in 1947 about decision-making processes in administrative organizations. This book was heavily based on Simon's dissertation and became the focal point of his life's work. The theme of this book focused on the behavioral and cognitive processes that occur when making rational choices, or decisions. Eventually, Simon produced what has been widely known as Simon's three-stage rational decision-making model. His model suggests that correct decisions being made in administration should be done in 3 steps. Further, the crucial task of choice should be divided into 3 required steps. 1. Identifying and listing all alternatives. 2. Determining all consequences from each of the alternatives. And 3. Comparing the accuracy and efficiency of each of these sets of consequences. It was Simon's emphasis on considering the alternatives that led to his concept of uncertainty as it pertains to decision-making. Although this concept was not new, it was Simon's organization of the idea that it's impossible for us to have perfect and complete information at any given time to make a decision that made his work so impactful. Simon became interested in a hot debate that appeared in the 1930s. This argument debated whether entrepreneurs needed to follow set guidelines in profit maximization and cost minimization, given these guidelines were not adequately supported empirically. The argument suggested that it was impossible to make perfect maximum profit estimates in business given the lack of complete information. That is, because we face uncertainty about the future, and thus the potential costs the future may have, we face certain limits in making rational decisions concerning the future. It is this decision-making process, in the face of uncertainty, that Simon coined the term bounded rationality. Bounded rationality suggests that we are limited or bounded to the extent in which we can make a rational decision. He felt that not only can we not get access to all information required, but even if we could, our minds would not be able to process it properly. Our mind necessarily restricts itself and thus is bounded by cognitive limits. He further coined the term satisficing, or the decision that we do end up making that might not be optimal, but essentially is good enough, given what we know and expect. He states, rational behavior in economics means that the individual maximizes their utility function under the constraints they face in pursuit of their self-interest. This is reflected in the theory of subjective expected utility. The term bounded rationality is used to designate rational choice that takes into account the cognitive limitations of both knowledge and cognitive capacity. Bounded rationality is a central theme in behavioral economics. It is concerned with the ways in which the actual decision-making process influences decisions. Hopefully this sounds a bit like my definition of heuristics mentioned earlier, mental shortcuts we use in the face of uncertain events or situations. They are thought to be mental shortcuts that help us arrive quickly to conclusions by reducing the amount of cognitive processes that may otherwise be necessary. Simon suggests that economic agents use heuristics to make decisions rather than a strict, rigid rule of optimization. They do this because of the complexity of the situation and their inability to process and compute the expected utility of every alternative action. Simon would go on to be awarded the Nobel Prize for Economics in 1978 for his theory of bounded rationality. His work, however, would go on to be the foundation for decades of psychology research to come concerning judgment and decision-making. Areas most influenced by his work can be found in literature concerning the psychology of expertise and intuition. Simon had a strong interest in the mechanical explanations of empirical phenomena. Simon first realized that experts suffer from the same cognitive limits as novices, mainly because 1. They can only pay attention to one thing at a time, and 2. Short-term memory is limited to only a few items. He also noted that for the most part, experts use similar strategies as novices. Heuristics. Simon and his colleagues performed numerous trials playing chess and assessing other chess players to illustrate that novices become experts by learning a large number of perceptual possibilities to lead to a particular outcome. He called these conditioned action pairs productions. For example, his research on chess players suggests that chess players perceive the board as chunks of pieces, and also that they chunk sequences of moves. Simons found this chunking technique to be essential to expertise as well as verbal learning. Intuition, therefore, according to Simon, then is really just the firing of productions, or using a learned pattern automatically. Many have criticized Simon's theory on intuition, suggesting that intuition is more than just pattern recognition, but a mental process that may creatively combine other elements to produce new solutions. After continuing to modify his theory, Simons eventually would help to develop a computer program that would mimic the eye movements of a master chess player that would essentially make the same mistakes and recovery moves. This simulation became the groundwork for Simon's fascination with computer programs that could mimic human problem solving. Simon figured that because computers solve problems similar to humans by using rule-of-thumb heuristics and means-to-ends analysis, computers must have some type of intelligence that, similar to humans, allows them to use efficient search procedures despite limiting processing capacity. Simon and his colleague Albert Noel would go on to develop the first artificial intelligence program called the logic theorist. The logic theorist proves 38 of the 52 theorems in Whitehead and Russell's Principia Mathematica. This program incorporated reasoning, heuristics, and list processing to mimic expert decision-making processes, essentially by working backwards. Simon later developed other groundbreaking artificial intelligence models such as the GPA and EPAM, which utilized ends-to-means analysis heuristics and chunking heuristic processes respectively. It was Simon's work with artificial intelligence that led him to amend his understanding of intuition. Simon believed intuition to be a function of bounded rationality, such that with experience and knowledge, intuition allows the expert to take the necessary shortcuts and avoid conscious calculation of how to solve the problem. The conclusion Simons reaches is that experience allows people to make judgments and decisions without the overanalyzing and calculating. Although expertise, intuition, and artificial intelligence theories have come a long way since Simon, his work was foundational for all these areas, making overlapping contributions to economics, psychology, cognitive science, decision theory, and organizational theory. His main contribution of bounded rationality became essential to his work on organizations, human decision-making, and ultimately, artificial intelligence. Thanks.